Hey guys, in this video we're going to talk about Chapter 3, Section 3, Converting to Factored and Vertex form. So we've converted from vertex to standard form before in previous videos, but let's just remind ourselves how to do this. So remember that standard form is y equals ax squared plus bx plus c. So this was our standard form. And our vertex form is going to be y equals a times x minus h squared plus k. So that's our vertex form. So here we're in vertex form. We have a is -2, h is 4, and k is 1, and we want to go into standard form. So the way that we can do this is we can expand, right? So if I write this in its expanded form, I have -2 x minus 4 squared means x minus 4 times itself, and then I still have that plus 1 at the end. So the first thing I'm going to go ahead and do is FOIL these binomials, leaving the -2 out in the front. So when I FOIL this, x times x is x squared. My outer term is x times -4, -4x. My inner term is -4 times x, -4x. And my last term is -4 times -4, which is a positive 16. So on the inside of these brackets, I can combine like terms, which are these two -4x's. That makes a -8x. So I get x squared minus 8x plus 16, and then I still have this plus 1 on the outside. So I'm going to go ahead and distribute this -2 on the inside to all of those guys. And I'm left with y equals -2x squared. -2 times -8x is a positive 16x, and a -2 times a positive 16 is a -32, and I still have that plus 1 at the end. So the last thing I can do is combine -32 and positive 1 to make -31. And this is my standard form. So this is my standard form answer. And here my a is going to be -2, my b is going to be 16, and my c is going to be -31. All right, so we can do the same thing if it's factored out. I mean, it's really the same process. We just have to FOIL again. So recall that factored form was y equals a times x minus r times x minus s. This was our factored form. And so what I can do first, again, I can FOIL these guys inside the blue brackets, leaving the 3 on the outside. So when I do that, x times x is x squared. So that's first. Outer is x times positive 1, that's a positive 1x. Inner is -4 times positive x, that's -4x. And last is -4 times positive 1, that's -4. All right, and from here I can combine like terms on the inside to give me x squared. These guys become a -3x minus 4. And finally, I can distribute this 3 to everybody on the inside. 3 times x squared is 3x squared. 3 times -3x is -9x, and 3 times -4 is -12. And now I am in standard form. And my a is going to be 3, my b is going to be -9, and my c is going to be -12. So this was a little bit of a review. What if we want to go from standard form to vertex form? So here's how we can do it. There's a little formula for it. The vertex of the parabola, if we're in standard form, the vertex h comma k is going to equal this. It's going to be -b over 2a is my h. And whenever we plug this, whatever number that is, whenever we plug it into the function to get our output, that's going to be our k. So that's going to be f of -b over 2a. So that's my vertex. So let's do some practice with this. First, number 1, we are in standard form, right? We're in y equals ax squared plus bx plus c. And to find the vertex, well, first of all, you need two things for vertex form. You need h, and k. In our case, a is going to be 1 because the a in vertex form is the same a in standard form. So a is going to be 1, and the question is, what is h and what is k? All right. So we're going to just use this formula to find h and k. Now, your textbook is going to show you a method called completing the square, which is a valid method, and you know, it's good to learn. So if you're curious, you can read up on that. But I'm gonna teach it this way. So, all right. So my h, the formula says that h is going to be negative b over 2a. So h is negative b over 2a. In this case, a is 1, b is 10, and c is negative 3. So negative b, we have negative 10 over 2 times a, which is 1. And then I can simplify this down to negative 5. So h is negative 5. Now k is just going to be whatever the output is when we plug in h into the function. So k is going to be, well, we're plugging in h into the function. So wherever I see an x, I plug in my h. Remember, h comma k is just an x comma y. It's just an input and an output. So that's k. So k is going to be, if we simplify this out, negative 5 squared, we get 25. This is negative 50 minus 3. So k is going to be, I'm getting lazy, don't want to think about this in my head, get negative 28. All right, so that's k. And now we have everything we need to put this thing in vertex form. So again, vertex form is y equals a times x minus h squared plus k, and we're just replacing a, h, and k. A, we already knew, a is the same as in standard form, so our answer is going to be y equals 1, which I don't have to write. X minus a negative 5 becomes a positive 5 squared plus k. Plus a minus becomes a minus. So this is our answer. And you can always FOIL this thing out and combine like terms to check that you get this original standard form answer. Okay, let's do number 2. So first of all, a, b, and c, this is in standard form. We have a is 6, b is negative 2, and c is 4. So I know that in vertex form, my a is the same, so a is going to be 6 as well. Now we need to figure out what h and k are. So h, again, my formula says that h is negative b over 2a. So b is negative 2. So I have negative 2. I can't get rid of that negative that was already in the formula. So negative b over 2a. And those double negatives on top make a positive. So on bottom I get 12, and when I reduce by 2, dividing top and bottom by 2, I get 1 over 6. So h is 1 over 6, and k is whatever I get when I plug 1 over 6 in for x. Okay, so let's figure out what k is. I'm just plugging in 1 over 6 for x because that's my h. And I'm trying to figure out what k is. Okay. So 1 over 6 squared is 1 over 6 times 1 over 6. Multiplying straight across, that gives me 1 over 36. So this becomes 6 times 1 over 36. And negative 2 over 1 times 1 over 6 is negative 2 over 6 plus 4. And you can just put this in Desmos in the calculator if you want. This becomes 6 times 1 is 6 over 36, which reduces to 1 over 6. Again, if you want to put this in decimals and just compute it out that way, that's fine. So what we get is 1 over 6 minus 2 over 6 plus 4. That's going to give me 23 over 6. So that is my K. All right, and so my answer in vertex form, remember I'm going from standard to vertex, is going to be y equals a, which is 6, times x minus h, which is 1 over 6, squared plus k, which is 23 over 6. This is my answer. All right, let's try another one. Just getting, our feet wet to practice this. So here we're in standard form again. Our variable instead of being x is t, but that's okay. We treat it the same way. So in standard form, a is -2, b is 3, and c is -1. So right off the bat, we know that our a in vertex form is going to be -2, and we need to figure out what h and k are. So h, my formula says h is -b over 2a, and b is 3, so h is -3 over 2 times -2. Simplifying out the bottom, we get -3 over -4, and those double negatives divide each other out to be positive. So h is 3 over 4. And let's see what k is. So k is just the output when the input is h. So if I plug in 3 over 4 anywhere I see a t, which is my variable, I'm going to get k. So I get -2 times 3 over 4 squared plus 3 times 3 over 4 minus 1. Okay. Now 3 over 4 squared, 3 over 4 times 3 over 4 is 9 over 16. So I get -2 times 9 over 16. And then 3 times 3 over 4 multiplying straight across is 9 over 4. So this becomes -18 over 16 plus 9 over 4 minus 1. And I'm just going to put this in the calculator. So -18 over 16 plus 9 over 4 minus 1. And I get 1 over 8. So that's my k. All right, and so my answer, my formula here in vertex form is going to be y equals a times x minus h squared plus k. Let's do one more. Okay, so the first thing I notice is that y is not by itself, so I want to make sure that y is by itself first. So this is my problem. I accidentally had the f of x there, but this is actually the problem. Y plus 1 equals x squared plus 2x plus 3. So I want to go ahead and get y by itself first so that it's in standard form. And to do that, I'll subtract 1 from both sides. Now y is alone and I'm in standard form. I get x squared plus 2x. 3 minus 1 is a positive 2. So this is my answer in standard form. And we can see that a is 1, b is 2, and c is also 2. So we can see that a is 1, so that's our a. Now we need h and k. So again, h is going to be -b over 2a. So we have -2 over 2 times 1. Simplifying this out, I get -1. -2 divided by 2. So that's h, -1. And now I just need to plug in -1 in for x to get k. So -1 squared is 1. This becomes -2 plus 2. And so k is going to be equal to 1. So my answer is going to be the following. It's going to be y equals a, which is 1, times x minus a negative 1, that becomes positive 1, squared plus k. So that's my answer. All right, find the vertex of the parabola. So this is nice because we're in standard form. We have a, b, and c. And so my h, all I'm looking for is h comma k. The vertex, I don't need to put it in the equation form this time. And I could if I wanted to, but it's just asking for the vertex here. So h is negative b over 2a, and in this case b is negative 3. A is 2. Simplify the top, double negatives make a positive, and the bottom becomes 4. So h is equal to 3 over 4, and k is going to be whatever I get when I plug 3 over 4 in my input, in for x. So I get 2 times 3 over 4 squared minus 3 times 3 over 4 plus 15. Now 3 over 4 squared, as we mentioned on the previous slide, is 9 over 16. And minus 3 times 3 over 4 is minus 9 over 4, multiplying straight across. And here, multiplying straight across, 2 times 9 over 16 is 18 over 16. So I get 18 over 16 minus 9 over 4 plus 15, and I'm just going to punch this in the calculator. And I get a weird number, but it's okay. 111 over 8 is my k. So k is going to be 111 over 8, and therefore my vertex is 3/4, comma, 111 over 8. So this is my answer. That's my vertex. Let's do one more. So again, we're looking for the vertex. We are in standard form, thankfully. So we can see that a is negative 1, b is 2, and c is 3. And my h is going to be negative b. Well, maybe I'll just write it again. Negative b over 2a. In this case, b is 2, so we have negative 2 over 2 times negative 1. And simplifying the bottom, I get negative 2 over negative 2, which gives me a positive 1. So h is positive 1. K is whatever I get when I plug in positive 1 in for my input. Okay, so k is going to be negative 1 squared plus 2 times 1 plus 3. All right, so PEMDAS says I need to do the exponent first. So I'm doing 1 squared first and leaving the negative multiplied in the front. So 1 squared is 1, so I'll leave it like that. So 1 squared became 1. And then 2 times 1 is 2 plus 3. So this is negative 1 plus 2 plus 3, which is going to give us 4. So k is equal to 4. And my answer here, as an ordered pair, is going to be 1, 4. That's my vertex. All right, so what if we want to go from standard to factored form? So we're only going to do problems where we have a equals 1. So here's the process. When a equals 1, we can do the following. What we want to do is we want to find two numbers that multiply to c, and at the same time add to give us b. Okay, so this is the little trick for how we can put quadratic equations in factored form if a is 1. So those two numbers are going to be are part of our factors. So these numbers allow us to factor. Let me show you what I mean by this. So I want to look at the first example. Now we are in factored form because we see A is 1, B is 9, and C is 8. Since A is 1, we can use this trick right here. If A is not 1, we cannot use this trick, but we're going to talk in the next video about how we can do something else. So, okay. So here's the trick. We want to find two numbers that multiply to C. So what we're trying to do here is find, with this specific problem, find two numbers that multiply to give us, what's C in this case? C is 8. To give us 8, but at the same time, add those two numbers to give us B, which in this case is 9. All right? So can you figure out two numbers that multiply to 8, but when you add those two numbers, they give you 9? What two numbers are those? Well, those two numbers are going to be positive 8 and positive 1, right? So the numbers are positive 8 and positive 1. And therefore, we can factor this to be y equals x plus 8, x plus 1. That's how we do it. And to check yourself, you can FOIL this back to see if you get your original standard form equation. So let's just check that out. We have x plus 8 times x plus 1. And we're going to FOIL this thing out. So first is x times x, x squared. Outer is x times positive 1, that's positive 1x. Inner is positive 8 times positive x, that's positive 8x. And last is positive 8 times positive 1, that's positive 8. Combining like terms on the middle, I end up getting x squared plus 9x plus 8, and that is indeed what I started with here. So I know that I factored it correctly. So that's how you do it. To find those missing numbers, positive 1 and positive 8, you find two numbers that multiply to your C value, but at the same time add to your B value. So let's do another example. And those, remember, those are our zeros of the function. So let's look at the next one. This time our variable is k instead of x, but no problem here. So we want to find two numbers that multiply to negative 16 but add to positive 6. So let's write it here. Multiply to negative 16 and add to positive 6. What two numbers are those? Well, I know 8 and 2 can make 6 by subtraction, right? And so we want them to add to positive 6. So I know 8 and 2 are going to be my numbers because they're going to make 6 some kind of way. And they both multiply to 16. But where does the positive and the negative go? So we want them to add to positive 6. So should I have negative 8 and positive 2? Should those be the missing numbers, negative 8 and positive 2? Well, no, because negative 8 and positive 2 make negative 6. We want it to be positive 6. So instead, how about the missing numbers be positive 8 and negative 2? So when I add positive 8 and negative 2, I do indeed get a positive 6. When I multiply positive 8 times negative 2, I do indeed get a negative 16. So check 1, multiply to C, and add to B is check 2. So the missing numbers are positive 8 and negative 2. These are our numbers. And so to factor this, we're just going to write, instead of x, like in the first one, we're going to write y equals k, and then, well, the first number we found was positive 8, and the second number we found was negative 2. And again, I encourage you to FOIL this back out just to confirm that that is indeed the same thing as k squared plus 6k minus 16. Okay, let's try the next one. I encourage you to pause the video, see if you can do this one on your own. So our setup is going to be, again, our answer is going to be in this form. Those two binomials. Again, our leading our a value is 1. And so we want two numbers that multiply to 8, to positive 8 in particular, and add to negative 6. So you want to start off by thinking about the factors of 8, numbers that multiply to positive 8. Now you know you're going to have a negative in there somewhere because you have a negative 6 to add to. So what two numbers are going to multiply to positive 8 that introduces a negative? Well, the only options we have to get a negative is, to multiply to positive 8, we can do a positive times a positive to get a positive, or we can get a negative times a negative to get a positive. But those are the only two scenarios that we're going to get when we multiply to positive 8. Since we're adding to a negative, I can logically say that it can't be this situation because there's no negative there. So I want two negative numbers that are going to multiply to a positive 8, but add to negative 6. So the factors of 8, we have 8 and 1, we have 4 and 2, that makes 6. And so my answer here is going to be negative 4 and negative 4, right? When we multiply, I'm sorry, not negative 4 times negative 4, I meant negative 4 times negative 2. So negative 4 times negative 2. These two numbers multiply to positive 8, and when we add them, negative 4 plus a negative 2, we get a negative 6, which is what we wanted. All right? Sometimes you have to, if it helps, you can guess and check. But I think the easiest way to do it is to just find those missing numbers right off the bat. Okay, so let's look at this one. This time our variable is b, so the setup is going to be y equals b in one parentheses, we have b in the other. And we want the following. Our c is negative 35 and our b is 2. So we want to multiply, we want to multiply to negative 35 and add to 2. So when we start with the multiplication bit. We want to find two numbers that multiply to negative 35. Now the only possibility to do that is a negative times a positive, or a positive times a negative. So we know our two numbers are going to be, we're going to have one negative and one positive. And so what two numbers, can we get multiplication to 35 and we get 2 is 7 and 5, right? 7 minus 5 is 2. So we have a positive 7 and a negative 5. When I multiply these, I do get a negative 35. That checks out. And also a positive 7 plus a negative 5 is going to be positive 2. That checks out. So our missing numbers are positive 7 and negative 5. And so we're going to have x positive 7 x minus 5. Or b in this case. And again, you can FOIL to make sure that's correct. And that's our answer here. All right. So let's look at number 5. Now notice that a is not 1, so we can't quite use our trick yet. However, what you should notice is that a, b, and c all have a number that we can divide out, right? So a, b, and c, I can make this a 1 by dividing everybody by 4 and pulling the 4 out. So if I pull the 4 out, I'm basically factoring it out is what they call it. If I pull that 4 out, well, the first one, 4x squared divided by 4 becomes a 1x squared. Negative 4x divided by 4 becomes a negative 1x. And a negative 120 divided by 4 becomes a negative 30. Okay. So I'm getting closer to my factored form because notice that this bit is in standard form, right, once we pulled the 4 out. And so in this case, our a is equal to 1, our b is equal to negative 1, and our c is equal to negative 30. So our question is, what two numbers multiply to negative 30 and add to b, which is negative 1? So I encourage you to pause the video and see if you can find those two mystery numbers. Start by listing out factors of 30. And when you look at the factors of 30, do you see any of those that would add or subtract to 1? All right, so the answer here, the missing numbers are going to be, let's see, negative 6 and positive 5. Right, because negative 6 plus 5 is negative 1, and negative 6 times 5 is negative 30. All right, so those are my missing numbers, negative 6 and positive 5, and therefore, let me rewrite this down here. We still have that 4 on the outside, by the way, and this standard form we can now factor, right? Whatever was in this set of parentheses, we can now factor because a is 1. So my missing numbers were negative 6 and positive 5. And this is my answer right here. Alright, so what we want to do here is we want to put the quadratic formula in factored form and use it to sketch a graph of the function. Okay, so remember factored form is going to give us our zeros. All right, so all of these things that we found are going to help us find our zeros. Now, what I want to do at this point is I want to find the zeros. I want to show you how to find the zeros for each of these guys. All right. Okay. So once we're in factored form, to find the zeros, we just set y equal to 0 and solve for x. So once we're in factored form, we set y equal to 0 and solve for x. And we want to find the zeros. Set y equal to 0 and solve for x. Okay, so basically what this is saying is we have two things being multiplied. One of them could be 0 or both of them could be 0, right? If we multiply a number by 0, it's still 0. So we have to set each factor equal to 0 and solve. So first of all, the x plus 8 we're going to set equal to 0, and then we're going to set x plus 1 equal to 0 and solve. So to solve this, I have to subtract 8 from both sides, and I get x equals negative 8. And over here, I can subtract 1 from both sides and get x equals negative 1. So these are my zeros. These are the x-intercepts, where the graph is going to cross the x-axis. So let's do one more example from this page. So to find the zeros here, we take our factors and we set them equal to 0 because we're setting y equal to 0. And actually this should have been k, not x. Got k plus 8 equals 0 and k minus 2 equals 0. Now we're going to solve for k by subtracting 8 on both sides here to get k equals negative 8. And over here we're going to add 2 to both sides to get k equals positive 2. And so these are going to be my x-intercepts, aka my zeros. So with that knowledge, let's try this one. So the first thing I need to do is put it in factored form so that I can set each factor equal to 0. So I want to find two numbers that multiply to negative 4 but add to positive 3. Now this is going to be easy because negative 4 doesn't have a lot of factors. So the answer here, what numbers multiply to negative 4 and add to positive 3 is going to be positive 4 and negative 1, right? When I multiply these two, I get negative 4, check. When I add these two, 4 plus negative 1, I get 3, check again. So in factored form, this guy becomes y equals x plus 4 times x minus 1. Okay? Now that I'm in factored form, I can set each of these guys equal to 0, right? So to find the zeros, well, we want to say 0 equals x plus 4 times x minus 1. So this could equal 0, this could equal 0, or they could both equal 0. So setting them both equal to 0, we get x plus 4 equals 0, x minus 1 equals 0, subtract 4 from both sides and get x equals minus 4, add 1 to both sides to get x equals 1. So these are my zeros, which means the parabola is going to cross the x-axis at those 2 points. So the first point is x equals 1, which I'm going to label right here. And the second point is x equals negative 4, 1, 2, 3, 4, which I'm going to label right here. So those are my zeros, and now I just need to figure out, another point on this thing, namely the vertex, to get a picture. So since I found the zeros, I'm going to go ahead and find the vertex at this point. Remember, the vertex is h equals negative b over 2a, comma, k equals f of negative b over 2a. All right, so here a is going to be 1 and b is going to be 3. So we have h is equal to negative 3 over 2 times 1. And maybe I'll just do it in steps like I did before. And that gives me negative 3 halves. And so to find k, I can just plug in negative 3 halves into my function. And by the way, you can use the factored version of the function if you like. You could also plug it in for x into the original standard form, but the factored form might be easier to work with. So I'm going to use the factored form. I'm just plugging in negative 3 over 2 anywhere I see an x into this factored form, because I'm trying to get my output for k. All right, so let's see. We have negative 3 over 2 plus 4. That's going to give us 2.5 right here, times negative 3 halves minus 1. That's going to give us negative 2.5. So when I multiply those guys, I'm left with negative 6.25. And maybe it'll be easier to write this in decimal form, the negative 3 over 2, to see it on the graph. If you convert that to a decimal, it's negative 1.5. So my vertex is at negative 1.5, comma, negative 6.25. It's h comma k, and I can go ahead and plot that to get a nice little picture. Okay, let's go ahead and graph this. Okay, so when x is negative 1.5, which is about right here, y is negative 6.25. So 1, 2, 3, 4, 5, 6, not quite halfway, but maybe right here. That's my vertex. This is going to be negative 1.5, negative 6.25. So this is h comma k, that's my vertex. And then again, my zeros are at 1, comma 0 and negative 4, comma 0. So now I can just connect the dots, make my parabola shape. We know it's opening up because a is 1, positive 1 in particular. And there's my graph. So zeros and vertex will help us graph. All right, here are variables v, but we can do this the same kind of way. Firstly, I'm going to find my zeros, and my function is v squared minus v minus 20. So I know that c is equal to negative 20 and b is equal to negative 1. So what two numbers multiply to negative 20 and add to negative 1? I'm thinking negative 5 and positive 4. All right, multiply them together, we get negative 20. Add them together, we get negative 1. So our factored form of this is going to be the following. So f of v is equal to v negative 5, v plus 4. So we can go ahead and find our zeros using this factored form by setting the y value, in this case it's f of v, equal to 0. So we have 0 equals v minus 5 times v plus 4, and we'll set these guys independently equal to 0 and solve for v. So here, if I add 5 to both sides, I get v equals 5. If I subtract 4 from both sides on the other one, I get v equals minus 4, and those are my zeros. So let's go ahead and plot them. So 1, 2, 3, 4, 5 is my first 0. And my second 0 is going to be at negative 1, 2, 3, 4. And let me erase some of this stuff. Okay, so this is negative 4, 0. All right, so I got those. Let's go ahead and find the vertex to get another point so that we can have a picture. So the vertex is, first thing, h is going to be negative b over 2a. In this case, we can see that a is 1 and b is negative 1. So we have negative, negative 1, just plugging in that, over 2 times 1. And that's going to give me a positive 1/2 for h. So for k, we just plug in the positive 1/2 into our input variable and solve for y. Now again, you can use the standard form, plug in 1/2 into v up here, or you can use the factored form. Doesn't matter, you're going to get the same answer. I'm going to use the factored form. So k, this is their factored form, is going to be 1/2 minus 5, I'm plugging in 1/2 for my variable, times 1/2 plus 4. And let's go ahead and evaluate this. So we get 1/2 minus 5, that's negative 4.5. 1/2 plus 4 is 4.5. So when I multiply these out, I get negative 20.25. So k is equal to negative 20.25. So my vertex is 1/2, negative 20.25. And I'm going to erase some of this to clean it up. And that's going to be my other point that's going to help me graph this. Now, this is kind of a big number, and we don't really have time to go down 20 units, right? So I'm going to say that let's make the y-axis go by 2s. So let's do that. -4, -6. Actually, let's make them go by 4s, even better. We can do that. So -4, -8, -12, -16, -20. Okay. So when x is 1/2, y is -20.25, so approximately right here. And it's not going to be the most beautiful picture, but there's my vertex. It's going up like that. And it should be a little bit rounder, but I think you guys get the idea. Okay. All right, so the quadratic expression is written in vertex form. Write the expression in standard and factored. So let's do standard first. So for standard, we just simply expand what we have. So we have x plus 2 squared, which is going to be x plus 2 times itself. And then we can FOIL this guy. So x plus 2 times x plus 2, x times x is x squared. X times positive 2 is positive 2x. Positive 2 times x is positive 2x. And positive 2 times positive 2 is positive 4. We still have the -1 at the end. Combining like terms, we get x squared plus 4x plus 3. So this is standard form. Now for factored form, I want to do my trick. Notice that a is 1, so I can do the trick. So for factored, we ask ourselves what two numbers multiply to c but add to b. So what numbers multiply to 3 and add to 4? That's going to be 3 and 1. So factored form is going to be y equals x plus 3, x plus 1. Okay, so that was standard and factored form. All right, so it says evaluate the expression at x equals 0 and x equals 3 using each of the three forms. So first of all, vertex is the one that we were given. So for, maybe I'll write that up here. Let's see. This is vertex. So for vertex, I have x plus 2 squared minus 1. So when I plug in x equals 0 for vertex, maybe I'll keep it in green. Just plugging in 0 where I see an x. So that's going to be 0 plus 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. So for vertex, when x equals 0, y equals 3. If I do the same thing for standard form is x squared plus 4x plus 3. At x equals 0, I get y equals 0 squared plus 4 times 0 plus 3. And that's going to give me 3 again, which is expected because these forms are literally the same function, right? It's just different forms. Same thing for factored. So for factored, we have y equals x plus 3 times x plus 1. And when x is equal to 0, we get 0 plus 3 times 0 plus 1. 3 times 1 is 3. So y equals 3 for that as well. So that is evaluating at x equals 0. We could do the same thing for x equals 3 for each of these. So when x equals 3 for vertex, plugging in 3 for x this time, we get y equals 3 plus 2 squared minus 1. 3 plus 2 is 5. 5 squared minus 1 is 24. So that's what we get when x equals 3 for vertex. When x equals 3 for standard, again, plugging in 3 where I see an x in my standard form, I get y equals 3 squared plus 4 times 3 plus 3. So 3 squared is 9, 4 times 3 is 12. And we get y equals 9 plus 15, which again equals 24. No surprise there. And finally, for factored form, when x equals 3, we get y equals 3 plus 3, it's 3 plus 1. Oops, not 9. 6 times 4, once again, is 24. So the point of all of this is that, you know, when you plug an input into either of these three forms, you're going to get the same output because they're secretly the same function. They're just written a little bit differently. Okay, let's do one more problem here. We're going to write the quadratic expression we're given right here in standard, factored, and vertex. So for standard, we're just expanding this out and combining like terms as much as we can. So we start with x plus 3 times x minus 7 plus 8 times x minus 7. So what I can do is I can first FOIL these two binomials in the front. X times x is x squared first. Outer, x times negative 7 is negative 7x. Inner, plus 3 times x is positive 3x. And last is positive 3 times negative 7, which is negative 21. And I can combine those now or later, it doesn't matter. Now for the second part, this is the distributive property. 8 times x is a positive 8x. 8 times negative 7 is a negative 56. And from here, I can combine like terms. So I only have one x squared. I have a negative 7x, a 3x, and an 8x, which makes a 4x, positive 4x. And then negative 21 minus 56 is negative 77. So this is my answer in standard form. A is 1, B is 4, and C is negative 77. Okay, so now let's do the factored form. So factored form, we look at standard and we say, well, we want two numbers to multiply to negative 77 but add to positive 4. And those two numbers are positive 11 and negative 7. Right? When I multiply those, I get negative 77. When I add them, I get 4. So my factored form is going to be y equals x plus 11 times x minus 7. And finally, vertex form. So vertex, again, I'm looking to standard to figure it out. Vertex form, I need A and I need H and K. So I already have A. A is going to be 1 because it's 1 in standard form. Now I need H and K. Remember that H is going to be negative B over 2A. In standard form, B is 4, so we have negative 4 over 2 times A is 1 in standard form. Negative 4 over 2 is negative 2. So H is negative 2. And K I can figure out by plugging H into the function. Now, as we saw in the last slide, we could use the factored form to do this because it looks easier. Or if you want to keep doing it how we've been doing it, you can plug in -2 in standard form. But you can also plug it in factored. It doesn't matter. I'm going to plug it in factored just because it's easier. Since my input is -2, that's my h, I get -2 plus 11, and then times -2 minus 7. So k is going to be 9 times -9, which is -81. And that's all we need. So we have y equals a, which is 1, times x minus a -2 is going to give me a +2 squared plus k. So this is my vertex form.